Hey guys, thank you for joining me. We are in day 14, or aka Unit 2, Topic 2, Solving Logarithmic Equations. Again, this is a little bit of a higher level where we're using properties and all of our algebra concepts, factoring. You guys seen that, depending on what type of equation is left over after we follow our regimen. All right, let's look at A. Guess solve each equation. We want to know exactly what it says. Solve each equation. And it means we want an answer that is numeric. Okay, here we go. How do we solve log equations? And everybody should be thinking aloud, convert into exponential form, or rewrite into exponential form. So we drop down that base, which is 3 to the second power equals our argument, which is 3x minus 2. Okay, notice the log expression is gone. We want to classify this type of equation. This is linear because we have a single x's to the first power. And we just simplify and move on. So here I'm going to do this. This will be 9, right? Simplify equals 3x minus 2. And we undo addition and subtraction first. And simplify as we go on. I notice log equations look more foreboding than they actually are. Okay, and then lastly, divide by 3 on both sides. And then I'm going to show you this down a bit. X is equal to 11 over 3. Just leave it alone. It's an improper fraction. It is what it is. It's our exact value. And we're done. Okay, if we substitute, it's a positive value. So we're going to be good. We don't have to check this one. Okay, so moving on along to B. We have e to a power, which seems like I'm going to make it a little bit clearer. It's to power. Maybe that's why I wrote so big, because I was in a different space. And we have to note that this is not log, this is exponential form. So again, we have two options. There's an old school option, which would be taking a log of both sides, what works out, but also we're going to apply the change of base formula. So I want to get a review of change of base. So we want to remember, and this is kind of going back, we want to remember that if we're looking at any value and applying change of base, it would be the log, right, of base B of A would equal some unknown value. Okay, so I'm trying to get this into the form that we're going to use. Change of base, it's all about that base. It would be log of B. And this could have been a natural log too, over the log of A, which would give us that same value. Okay, so in this case, when we are changing, I want to get this into exponential form now. If we were to write this in exponential form, it would be B to some unknown power, which is the form that we're given here, is equal to A. And that would be A is that old exponent. So we have this form. So now all of these are equal. Let me just box this. And now we can apply it to this particular problem. It would be log of base E of A is equal to our exponent. So I'm just going to write here, change of base. Change of base E of 8. So what does that look like? Let me make this a little bit more legible. Okay, so that looks like this. Change of base E. So it would be base on a bottom. Get my fraction on it. It would be ln of E over ln of 8 equals our exponent 2x plus 5. Yeah? And this is your change of base. And notice, like way over here, log of base going from exponential, log of base B of A. Okay, that's going to equal your exponent if it's over there. Okay, so now we have to solve for x. Looking at the x, this is linear. You take away 5 from both sides. Now be very careful when you take 5 from the left side. This is a fraction, which is a family. So it's ln of 8 over ln of E minus 5 equals 2x. This can be simplified. I don't know. We could have addressed it up here. We could have addressed it here. I wanted us to kind of just get to 2x to see that that goes outside. This denominator is special. It will cancel out. Let me show you why. This becomes the ln of 8. Now you have to remember, and this is the hardest thing, that this is the natural log. I'm going to write is base E of E. Because these are inverses of each other, this just cancels out to 1. I'm just going to copy the rest so you know that it doesn't disappear. A number composed into its inverse will undo and you'll be left with 1. So this simplifies to a natural log of 8 minus 5. Let me just put that 1 here. Equals 2x. Divide by 2 on both sides. All of this. And x is going to be equal to, right here, x is equal to natural log of 8 minus 5 over 2. Boom, that's it. And I'll just box this in. So it's how to use that change of base formula. Okay. And I can show you the other method. We could do that later, but I want you guys to practice this. Again, the biggest clue is that there's no log expression. And we just went through all those transformations. You could take the log of both sides and you get the same answer. And we'll look at that later. But change of base E of 8. Okay? And then I wrote here. All right, let's do the next one. And if we see it, we get blocked. Use change of base. Applying properties, you can see you have your power property right there. So let's go ahead and string that together. So log. Remember, this is the common log. It has a base, but we're not focused on that right now. We're applying properties, okay? And that property is the quotient property. And right now, what we're looking at is the power property. I'm going to do these in steps. So this would be 2 to the 4th power minus this thing stays, which would be log. Yeah. All right, now I'm going to go ahead, consolidate. This is our quotient property, 4. 2 squared is 4. X plus 4. Yeah. Then you say to yourself, how do you solve log equations? You have to remember convert to exponential form. You need a base. This is the common log. Common log is base 10. So this would be 10 squared is equal to 4 over x plus 4. Okay, you have to know this is a fraction. Anytime you have a fraction, you can make up a whole number into a fraction. And we're classifying this problem again. This is called a proportion. And proportions are solved by cross multiplying. Okay, so I'm just going to rewrite 10 squared. We should know is 100. So it's going to be 100, which is a whole number over 1. We do that to have some comfort equals 4 over x plus 4. Cross multiply, and you get 100 times the denominator across, which is x plus 4 equals 1 times 4. So multiplying this out, distributive property, 100x plus 400 equals 4. And do addition and subtraction, or subtraction. It's linear. Okay, and as I do that, we get negative. This is going to be negative 396. Divide by 100 on both sides. It's a big number. So I'm not intimidated. That's going to be a big number. And we get our answer, which is x is equal to. Now we could divide this. You should be able to see, again, if we simplify this, that 4 can go into each of these. I just get that clue from one of the tables. I'm going to make sure we see that it's a negative value, so I'm going to just put that negative sign in a different color. And if I'm dividing everything by 4, what goes into the 36 is 90. That's 36, 3 left over, 99 over, and 100 divided by 4, or 4 quarters. And this is your answer. Yeah, well, it doesn't look pretty, but it's not supposed to. It's never. The world is pretty only sometimes. That's why we cherish things. It is what it is. All right, D is, again, analyzing a product property. So it's going to look like this. Consolidate your log base 2. And then you're going to multiply x times x plus 3 equals log base 2 of 18. All right, we talked about this. If you have log base 2 on the left and log base 2, it has to be there, which it is. We can cancel these out, and because they are equal. And then we can actually go ahead and step multiply, which is x squared plus 3x equals 18, only if there's the same log base 2, or whatever it is. I'm saying it has to be on both sides, which is here, it's 18. Classify this equation. It's an x squared. It means it's quadratic. We solve quadratic equations by setting the given equation to 0, making sure that x squared term is positive, and factor. Okay, looking at our constant, which is negative 18. That tells us our signs are going to be one is positive, one is negative. We factor x squared. We factor. We're writing a multiplication example for which the given is your answer. Now we're looking through our family of multiples for 18. And we're trying to get 3. So I was like, oh, I was already thinking about 3 and 6. 3 times 6 is 18. We want the 6 to be positive because it's bigger, because you have to also subtract it. And we will add them. 6 minus 3 or plus negative 3 is positive. 3x, so positive. So that's right. Set each factor to 0. Solve this. Uh-oh, we're going to have a negative number, so we're going to have to check that. Summation. And let's see. So x equals negative 6. And x equals 3. All negative values have to be checked. So let's see. All right, so I'm going to get the original. And I can see right here, just plugging it into that first part. You could look, you cannot have an argument that is negative. So this one is rejected. Again, we just go into our test. If one of those factors in one part is negative, because they have to go together, everything is at the same time. We reject the whole thing. So I'm just going to rewrite that check so you can see it. I want to do one clear check. And I'm just looking at, I'm just like check. I'm looking at the original, which is log base 2 of x, right? What do we substitute? It's going to be log base 2 of negative 6. How do you see that in exponential form? Pretend we go into, again, I used to say set it equal, say log expression set it equal to y. So means an open box, same thing. So it's 2 to some power equals negative 6, and this cannot be. Yeah, output must be positive. Okay, so again, can't have a negative argument. Which is your x, cannot be negative. And it's easy to see in the exponential model. All right, so we did a nice job of that check. And that just has to go for all the negative values. Let's look at this one. I don't know if I checked this particular one. Let's go back because this is negative. Let's go ahead and see. Well, it looks a little weird. I'm looking at the original. So the only process with an x is here. So let's check. Let's check. So I'm just going to get the part that has the negative value, which is log, or has the variable of x plus 4. Right, because the other one is just a number. Okay, so now what we're looking for is, let's see, if we have this value plus 4. Now 4, remember, you can outdo all the steps. For 1, we need to multiply everything by, because you can only add fractions that have the same denominator. So I'm going to convert. So I have to multiply the top and bottom by, and I'll put it over here, by 25. And 4 times 25 is a quarter. And 25 on top, 25 on the bottom. And you can see that this will be positive. So therefore we keep it. Make sure we do that. So this is positive, which will be 1 over 25, which is positive. So we keep. Yeah. So again, I just made that check at the bottom so we could see both sides. Okay. Make sure you do that. All right. It's nice as we could go back and check later, which we did. All right, those are homework answers. Remember, all you have to do is show your work. It's there. I'll take questions a little later, but you should have that. All right. Fold a piece of paper into quarters. Complete the problem, one in each box. Use both sides of the paper. Okay, so they wanted us to copy the problem, solve them. So I have what I did beforehand to prep. I put the other problems on the back so we can see it. I need more space with this one, so I'm just going to delete this box because I already know that, so we can have more space. Okay, so here is going to be 1. And I'm just going to draw my lines because I'm not really that great with lines. Let's make them purple. And for right now, we're just going to do 1 over here. And I'm going to, of course, rewrite it. I'm not going to put solve because that takes up too much room. So I'm going to put log base 5. Parentheses, make sure you're copying the problems when you do your homework. Okay, I'm going to do 2 over here. Just copy it down. And this is 2 log base 2. Log base 2. 2x minus 1 equals 5. I just made it. All right, first thing we want to do here, again, how do you solve log equations? Rewrite in exponential form. It's all about that base. So it's 5 to the 2nd power equals 4x plus 11. Simplify. So if we simplify, this is going to be 25. 5 squared is 25 equals 4x plus 11. It's linear, so all we have to do is take away 11 on both sides. Summation line. And 25, if this is 14. Right, it's positive. Don't have to worry about now what we do is divide by 4 on both sides. So you need a lot of room for this. And we have x. And we want to simplify this. A number divided by itself is 1x. And all even numbers are divisible by 2. So 14 divided by 2 is 7. And 4 divided by 2 is 2. And this is your final answer. Yeah? Okay. Breathe in, breathe out. 2. We're going to apply your quotient property, consolidate this log base 2. So it's going to look like this. Log base 2 quotient property, you need fraction. And this is going to equal 5. I want to put everything in there first. Top is x plus 5. First come, first serve. Denominator is 2x minus 1. How do you solve log equations? You rewrite into exponential form. So it's all about that base, 2 to the 5th equals x plus 5 over 2x minus 1. Okay, almost there. Simplify. 2 to the 5th power, I believe, is 32. Yeah, we should know that. So this becomes 32 over 1. Remember, this is our proportion. Once you have a fraction, you can convert the whole number and left into a fraction. Cross multiply. Okay. So it's going to be 32. And it's a big number, so I'm just going to write now. Times 2x minus 1 equal between them. And then this is 1, just so you know we're doing the same thing. We could have just put x plus 5. Okay, simplify. So I haven't done this in a while. 64 x minus 32 equals x plus 5. Yeah, okay, almost done. Let's see what we do. It's linear. So we could subtract x on both sides. We get 63x minus 32 equals 5. Linear, add 32 to both sides. Create a summation line. 63x equals 37. Divide by 63 on both sides. And we've got a number divided by itself is 1, so this is going to be x equals, and I don't think this simplifies that. It's just the basic math. Not so pretty, but it's beautiful. Yeah? All right, so that was 1, 2. Went a little longer, which is section in the paper. And I'm going to write number 3 here. You see? And I'm just getting it from up here. Okay. So 3. I'm going to write it from my paper. Always number your problems when you do your homework, please. It's very important with your organization. Number your problems. So this is log base 8 of x plus, I'm just copying it from log base 8 of x plus 6. And equals log base 8 of 5x plus 12. All right, this problem. Let's go ahead and consolidate product property of logs. So log base 8 of, and it's going to be x times x plus 6. That's our left side equals, we just copy it right. That's what I'm saying. Log base 8 of 5x plus 12. Okay, again, this is that particular problem where it's on both sides of the equation. You have log base 8. If that exists, we can go ahead and cancel these out. Well, I'm going to apply the distributive property. So that's going to give us x squared plus 6x equals 5x plus 12. Combine your like terms on opposite sides. So quadratic equal to 0. I'm using these in 2 parts on 1 part. That's it in 2. So we have x squared minus 5x. Oops, I have to add. You add that, it's just positive x. Remember, plus its opposite is 0. Take away 12 on both sides. And we get x squared plus x minus 12 equals 0. Okay, how do you solve quadratic equations? U factor. And we'll get this. 0. Minus means that you'll have x plus and x minus. We want to factor. Find 2 numbers close together where you only get 1. We have a coefficient of 1 here. And that's 4 times 3. 4 times negative 3 is negative 12. And 4 plus negative 3 is 1. Set each factor to 0. solve accordingly. It's linear. Summation. We have x equals -4. We're going to have to check that because it's negative value. And we have x is equal to 3. All right, looking at the original, trying to see and substitute. If we put or substitute -4 right here, as you can see, it will make that argument negative. So I'm going back to log base 8 of x. Looking, you can't have an argument that's negative. I did that mentally. This is a reject. And this is no answer. No. All right, last one on this page. We got some more on the back to cause our practice. All right, let me write the problem first. Then let's see. It's 4. And 4 is log base 6 of x plus log base 6 of x minus 9 equals 2. Yep. Yep. Okay, apply our properties, product property, which is log base 6 of, it's going to be x times equals 2. Rewrite in exponential form. So 6 to solve with the base equals, I'll multiply this out now. X squared minus 9x. Yeah, it's quadratic. Solve quadratic equations or solve by factor. 6 squared is 36. Summation line. We get 0 equals x squared minus 9x minus 36. All right, 36 is a big number. There's a lot of factors. We want whatever atoms we have, or we want whatever pair we have to equal 9, or -9. So we go through them all. 1 and 36. Nah, it's not going to be 9 in any way, shape, or fashion. 2 and 18. Nope. Dig deeper. Then it's 3 and 12. Yep. Because 12, right, is larger. It's going to have the sign of the middle term, so it's going to be -12. We have our factors. So it's going to be 0 equals x plus 3 and x minus 12. Set each factor to 0, and it becomes routine. X plus 3 equals 0. X minus 12 equals 0. Subtract 3 on both sides, so if we get a negative, gotta check that. But we're just taking our time. So we have x equals -3. Oops. And x equals 12. Okay, let's go ahead and substitute. All right, tick box, we got to check. Check. All right, it's great. I love it when they just have the example in the original where it's just x by itself, so we don't even have to do any math. That definitely will make the first, what we call factor or argument, negative, so we reject. And this is our answer. Okay. You guys want to see some more? Of course. All right, so let's go ahead and look at the next step. See, they're all up here. I'm going to do the same thing. Divide your paper. So I'm going to write 5 and copy it. This one looks a bit longer. It's fine. use this space, which is log base 4 minus log base 4 equals 2. All right. These, again, you want to recite your order of what to do. All right. So anytime you see ln, how do you solve log equations? You rewrite them in exponential form. But notice, we don't have a base that we can see. So you have to know that this ln is log base e. So it'll pop out. Right? Now we can rewrite this in exponential form. E to the third power equals. Don't worry about it. We'll just leave this. This represents a number. We're not worried about that. Our job is to solve for x. So if our job is to focus on x, undo addition and subtraction, order of operation. Right? Again, top to bottom, left to right. This becomes e to the third plus 5. They're unlike terms, so we have to separate them. Equals 6x. Divide by 6 on both sides. Both sides means the e cubed and a 5. And that's our answer. So what? Yeah, we're done. It's a complex number, but yeah. All right, here we go. Let's do the next problem and we can partition this. Helps keep their focus. Okay. Quotient property. Log base 4. Gonna have a fraction line. Equals 2. We got all that work. All right, on the top is what's first. Bottom. Okay, how do you solve log equations? We write them in exponential form, which we're ready. So this becomes 4 squared equals classifying this type of equation, which is a proportion. And proportions are solved by cross multiplying. So 4 squared is 16 over 1. Copying this down. And cross multiply. So this becomes 16 times the denominator that's across from it. Plus 1 times 3x plus 2. So we already did that 1 times 6 is 3x plus 2. Or 3x minus 2. All right. Multiply. And I had to kind of do this in my head because we're trying to not use calculators, right? 4 times 6 is 24. 32. 4 plus the 2 is 64. Plus 16. Algebra 1. Combine with terms. Same on opposite sides, you do the opposite one. I believe it's 61x plus 16 equals negative 2. Subtract 16 on both sides. We get 61x equals negative 18. Divide by 61 on both sides. Then we get x is equal to negative 18 over 61. All right, now because this value is negative, we have to check. Right? So let's go ahead and check it. All right, into the original. So I guess when I checked it, I looked at kind of any one of these sides to see. So I'm going to squeeze the check over here. All I have to do is prove one of them is negative. So we're going to take the original, the 3x plus 3x minus 2. So we'll just write everything. Log of base 4 of 3x minus 2. That's what value I'm substituting. This is negative 18 over 61 times 3, right, minus 2. All right, so again, it's hard to, I mean, it's not that hard. We just have to see what's it's going to be in the end. So 3 times negative 18, it's going to be a negative value. So 3 times 24, carry the 2, that's 54 over 61, minus 2, that's 38. So I got to convert. This will be 61, right? Multiplying by 61 on top and the bottom. So if I multiply 61, this will be 112, because I'm just multiplying this by 2, and then 2, it's 12, yep. And you got a negative number, you're subtracting, this is going to be negative. All I have to do is get here. It's a negative value. This is reject. And therefore, our answer is, which you can have, no solution. Oh, that was intense. All right. Remember, you cannot have a negative value in the argument. All I did was this unapplied. Okay. Let's see what we have here. That was 5, 6. So now we're going to do 7. And 7 is log base 3. X squared minus 6x equals 3. Rewrite. How do you solve log equations? Rewrite in exponential form. You can already see it's quadratic. 3 cubed is 27. 3 times 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. Set that quadratic equation equal to 0. Making sure the x squared term is positive. And then how do you solve quadratic equations? That's right, ladies and gentlemen. Refactor. All right. You're going to have plus and a minus. All right, 27. What comes to mind right away when I see 27 is 9 and 3. Right? 9 is going to be negative. It's bigger than 3. Yep. If we add them, we get negative 6. All right. So now we have to do is set each factor to 0. Undo addition or subtraction. And we have 2 values. We got to check that negative one. X equals negative 3. X equals 9. Right, let's see. And mentally checking negative 3 into the original. Oh, wait, since this is the original problem, we got a little bit of drama. So I just put it in here to see. Let's see if there's no X by itself. So Here we go, rewriting the first part. So I'm going to write check. And I'm just going to write it log base 3. And it would be, you can kind of factor this if you'd like to take that out. Or we could do it inside. I don't know what you guys want to do. But I'll start with this presentation because we're only working with 3. Okay, so our value is -3. So -3 squared minus 6 times -3. Let's see, -3 squared is 9. And this would be plus 18, and negative times negative is positive. Looks like it could, but in factored form, because it's going to, if we substitute this negative, because we have to square it, and then here if we multiply it, that comes up to plus. So, but what if it was positive? It would be 3, which would be 9 minus 18. So that's the other trick. So if we put, that it says it's -3 and then 9 seems to work. We're just substituting 981 minus here for 9 or 54. Looks like they both work. So again, I'm thinking, because it has it, and this is pretty hard to tell to convince you, because if we factor this is -9 and we have to square it. But this, because it's in factored form, we gotta look to see, do we keep or reject? Because this could be factored. And this is what I'm talking about. That this would be x times x minus 6. And here, if we have the x on the outside and inside, we would definitely have to reject it. So, decisions. I say, because in factored form, that it will be a negative value. It doesn't really come from here, and then you have to look at it, because this would be here that we would reject because of the factor, because this comes from someplace else. Okay, looking at the presentation, that's tricky. I'm gonna have to check and see back with that. So we did everything else, blah, blah, blah. Because that argument didn't come from factored form, but if we take a deeper look, it will. So it has to be, the argument has to be positive. So that's why I would look at it from that way. All right, here we go. I know that was tricky. We'll get back to that one. Okay. Let's look at the last one, which is 8. And 8 looks like this. Okay. Now this is the common log. Okay. Consolidate, quotient property. Top, bottom, equals. Okay, got logs on both sides. Love it. Log on both sides, you cancel them out. This is log base 10. Doesn't matter, they're both on the same side. They're the same. Okay, this is our famous proportion, which in higher math to cross multiply. So this is going to be 2 times equals x minus 3, or x minus 2, 1 times. All right, and then here I'm just going to put the different column. Multiply. Again, distributive property. Add, subtract x on both sides. We have 3x. Add 6. 3x equals 4. And x looks like it's going to be 4/3, which is positive. Okay. Positive, yeah. Let's look at the substitute in here. Ugh, that substitution, we definitely want to check it out, because looking in here, 4/3 minus, just to see how it's impacted for it. If we convert, let's go ahead and take the opportunity to try that. That's like a 1 point something minus 2. That might be negative. So let's look. So I'm just looking at the top. So I'm going to take this down. So it depends on what you're given. So I'm checking, right, to see if we reject it or not. And it is log of x minus 2, which is going to be our x value is 4/3 minus 6/2, 6/3, because it has to be 2. So we're looking at this. We're going to make that denominator 3. We're going to make this denominator multiply by the same thing, which is 6. Notice this is going to give a negative value. It looks like it's going to be negative 2/3. So I'm going to show you this down. Our argument is negative. You can't have a negative argument. So for this one, we reject, and it's no solution. How did I know to check? I don't know, because fractions are small, and I noticed that it was leading here, and you're going to have this value. We had to go in. That's how I knew that. For this one, even though if you substitute, you get kind of a positive value, but you have to know it stems from a greater place, which is if this is in factor form, and you want to look into the simplest form, and because this leaves us with an argument that's out, we reject it. So again, always factor. So that's why we're rejecting it. Okay. Looking at anything else. Let's see, we've done 1 through 8. They're kind of tricky. I don't think you're going to have anyone that's that tricky, but you should be able to see the context. All right. We are done for today, and we'll look at Q&A in a second. All right.